whilst we begin the lesson. Welcome to Edude Academy. Today's session, we will be looking at the objective, and from there we look at few problems as to how we can deal with. Whilst we are doing this, we'll be welcoming your friends who are still joining the class, though they are in late, but there's no problem. By the end of today's lesson, you will be able to define tangent and radius. You will be also able to identify angles in the same segment, define tangent and chord theorem, prove tangent and chord theorem, identify properties of cyclic quadrilateral, solve problems relating to cyclic quadrilateral. So as we keep moving, you'll be able to see that there are instances where you've done few theories from grade 11. We also have to look at them. So let's look at the first one, which is here. Here is the theorem of tan radii theorem. Okay, so you have a circle that has a radius. So this is our radius. And then this is the tangent to the circle. So if a tangent meets a radius, the angle formed between a tangent and a radius is 90 degrees. That is what we say. So whenever you are answering an exam question, you must remember that the angle between a tangent and a radius is equal to 90 degrees. Then we come to the next diagram, where you look at angles in the same segment. So when the angle is in the same segment, you have to look at a diagram that looks like a bow tie. Okay, it looks like a bow tie. For example, if you look at the diagram on my left, this angle here should be equal to this one. And obviously this one is also equal to this angle. This is what we call angle in the same segment. So this angle A here is the same as angle B here. And then when we look on the right, we also have angles in the same segment. All right, so this angle here is equal to this angle here. And obviously this one is equal to this. This is what we call the bow tie, and others call it the butterfly. So the reason why I'm going over this is that you're going to meet questions that you have to apply this knowledge. Now, tangent and chord theorem states that an angle formed between a chord and a tangent line to a circle is equal to the inscribed angle on the other side of the chord. You can also say it as the angle formed between a chord and a tangent line to a circle is equal to the angle subtended by the same chord in an alternate segment. And we'll look at that also. Remember, you've done this theory in grade 11, so we're just going over before we start the final exam question. So here we are looking at tangent and chord theorem. Before we go to solve a question, remember that this is a tangent, okay? This line is a tangent. Now, a chord is any line that divides a circle into two, but not two equal parts. Remember the story. So this one is one angle. Now, remember when you are doing in trigonometry, you are doing your sine rule and the cosine rule. You have a triangle, and then you have these lines that are opposite the angles that you have formed. So what obviously happens is that you will say each line subtends an angle. So this line here subtends this angle here. So if this chord subtends this angle here, then the angle B here must be equal to the angle which is here. Here there is another angle A. It lies between this chord and this tangent. So this angle A is also equal to this angle A in the opposite segment, or what we call the alternate segment. So that is another thing you need to remember. We move to the next one. Now, this is where we come to a point where we have to understand how to solve exam questions. I have taken this question from Mathematics Paper 3, November 2011, question 8.1. Now, what happens is that in the past, schools were writing Maths Paper 3, okay? So, in Maths Paper 3, a lot of questions on Euclidean geometry is there. Now, what we need to do is to see what type of question we are given here. Okay? It says that in the diagram below, O is the center of the circle, PQ is a tangent to the circle at A. B and C are points on the circumference of the circle. AB, AC, BC are joined. Prove the theorem that states angle CAP is equal to angle ABC. Now, what theorem are we talking about? Angle CAP. Let's look at angle CAP. Angle CAP is here. And the angle you are supposed to prove is angle ABC. So this is the angle. Now, so if you have to work on this, you need to be very careful. But the question is, why have you been asked to prove these two? Because we looked at the theorem earlier. This angle lies between this chord and this tangent, and therefore this chord here, AC, subtends angle B. Therefore, angle B is opposite this chord. Therefore, it must be equal to angle A1. Now, to prove, we need to construct. So the first thing we need to say is to construct some lines. What lines are we going to construct now? We have to construct a diameter. So we will say construct, okay? Construct diameter, and the diameter, you need to name it yourself, okay? You need to name the diameter yourself. So if, for example, we are trying to construct a diameter, what we need to do is to ensure that your Leonard, can you turn your mic off when you join the lesson? All right, so what you need to do is to make sure that you construct a diameter. The diameter you're going to construct, you are going to name it by yourself. Are you following, Leonard? So you are going to name that diameter by yourself. So let us say we have diameter AB, okay? If you have diameter AB, what is going to happen? Are you getting it? But we already have an alphabet which is letter B there. So you cannot say you have diameter AB. So here we are going to say from this point, because this point A is connected to the chord. So we start from here. We take the line, we pass through the center, then we go to the circumference of the circle. Now, because there is no alphabet here, I can give it a name. But if I'm labeling it, no alphabet must be the same as that one. So let me use K. I'm using letter K here. So we are going to say construct diameter AK, okay? So we construct diameter AK, all right. That's the first thing, and the examiner is going to give you mark for that. The next thing is you need to join this K now, either to C or to B. Now, but because we are proving that this angle A1 is equal to angle B, I would rather advise that you connect K to B here. Okay, so this is what happens. So you are then going to say join, okay? You are going to say join. Which letters now? K, B. So we are joining KB. So as we join KB, what is the next line of action? All right, now we're going to understand something very important. We are going to see what are some of the theories we can identify here quickly. All right, when we're doing the lesson, I told you about a diameter and a tangent, okay? Another name, you see a diameter, half of a diameter is radius. So you can say tangent diameter or tangent radius. So now we have a theory. A theory is what? Tan radii theorem. So I will say tan dot radii or radii, tan radii theorem. What does tan radii theorem say? It says that the angle between a tangent and a diameter, or a tangent and a radius, that angle is 90 degrees. We are talking about this one here. So that angle is 90 degrees. All right. So we are saying that angle, we can call this one, if you want to make it simple, you can call this one A2. Okay. So what we are saying is that we have to say we have, permit me to write here, I have angle A1, okay, angle A1 plus angle A2, okay, is equal to 90 degrees. And what is it? The reason has been given here because of space. So angle A1 plus angle A2 is equal to 90 degrees. That is tan radii theorem. Let's look at another one. We have to look for another 90 degrees again. Now, you remember one thing you learned in grade 11 is that when you have a diameter and the diameter subtends an angle, or that diameter is part of a triangle, the entire angle on the circumference is equal to 90 degrees. Okay, so we can also call this one, let's say B1, B2. Okay, so we would then say angle B1, okay, plus angle B2, okay, is equal to 90 degrees. And what is the reason? You can say angle in where? A semicircle. Angle in a semicircle. All right. That's one thing. Now, but don't panic, because you can also say angle subtended by a diameter. Okay? No one is going to penalize you for that because it is a diameter that subtends the angle. Okay, so now look at it. When you are proving ten-chord theorem, you need to show that two angles are 90. We've done that already. Now let's look for another one. Look at this. Do you remember the bow tie story? The story of the bow tie I showed you earlier, or the butterfly. So we can now say that angle C, okay, is equal to angle K. And for this one, the reason will be what? Angles in the same segment. Angles in the same segment. Okay. That's fine. Now, what else are we going to do? Remember when we have the bow tie, two angles on top, two angles at the bottom. So if this angle here is equal to this angle here, then look at it. Let me show you something. You see, you go like this, you come like this. So which angles are we looking at now? We are looking at angle A2, okay? Angle A2 to be equal to what? Angle B2. And the reason is what? Angles in the same segment. Now, what we are doing now is to make sure that we have all the theories. So remember when you're proving this, two angles for 90, two other angles, two pairs of angles for 90, and another one for angles in the same segment. Now guys, look at this. I want to show you something. See, if the whole of this angle is equal to 90, and the whole of this angle is equal to 90, and we say this angle here is equal to this angle here, then obviously this angle B1 is also equal to angle A1. So then you will say, therefore, okay, therefore angle A1, okay, is equal to angle B1. And the reason is what? tangent, and chord theorem. You can write it in shorthand chord theorem. We have many ways of doing it, but I believe you will like this method. And those of you who are attending the lesson, I will upload the video for you so you can revisit the video and watch it. Now, what else you can say is that because the examiner didn't say A1 and B1 and all that, this is what the examiner say. So you can say hence, okay? You can say hence, your angle CAP, okay, is equal to angle ABC. Okay, so CAP, which is angle A1 here, and then angle ABC, which is angle B1 here. So that is the solution for the first one. Take time and have a look at it, and then we move on. Thank you. Now we'll be going to the next stage, and I want you to look critically. Under this, we'll be looking at things like triangles, and we have properties of a triangle, okay? So some of the properties of a triangle which you need to remember is that if you add the interior angles of the three interior angles of a triangle, it will give you 180 degrees. And also, because it is a triangle, the word tri, it stands for three, so which means that it is a polygon that has three sides and three edges and then vertices, okay? And then we have the exterior angle of a triangle is equal to the sum of interior opposite angles. Remember that story. You know it, and I believe that you won't forget when we get to the question. And here you look at it, this one, you look at this triangle here, the scalene triangle. Why is it a scalene triangle? It says all sides are different. Here, isosceles, you know, two sides are equal. That is why in Euclidean geometry we have angles opposite equal sides as a reason. Okay, then we come to equilateral. All the three angles are equal and all the sides are also equal. Then we come to acute angle. None of the angles is more than 90. Each and every angle here is less than 90. All right. So what will happen is that learners, you don't have to go anywhere. When this time is over, when the lesson is, the period is over, hold on. I'm going to send you again the second link via the chat group. Then you join the lesson. So no one is going anywhere. Okay. So that is the first thing to remember. We have 9 minutes left, but don't go anywhere. I will send you another link so that you join the lesson. So you check your chat group in the WhatsApp group. All right, so that is one other thing we need to look at, okay? So we are looking at a situation whereby you find a question in exam and you don't know what to do because it is a triangle. Then when we move on, we look at what we call the cyclic quadrilateral. For the cyclic quadrilateral, you know that when all the four vertices or the four corners of a four-sided figure are lying on the circle, on the circumference of the circle, then obviously it is a cyclic quadrilateral. So take note of that. It is very important. Then we also know that the exterior angle of a triangle is equal to the sum of interior opposite angle. You know, so we've done that also, but this is a diagram to show you about it. Now, we've also discussed about the properties of a cyclic quad. So this is the property, and you have the video. I said it, when you add the interior opposite angles, it will give you 180, or the exterior angle of a cyclic quad is equal to the opposite interior angle. This one too, you have it there. So, for example, if you look at something like this, you have a diagram where the angle here is the exterior angle. It must be equal to the interior opposite angle. But if you take this angle and this angle, if you add them up, it must give you 180 degrees. So those are, if you add these two, they are not equal, guys. They add up and they will give you 180 degrees. But the exterior one and the interior one are equal. Okay, that is another thing you need to remember. Now we move on to the next level. Whenever you see this bow tie diagram, you remember this, angles in the same segment. This one and this one. So obviously this one and this one. We can also turn it like this and this one. You see that? Then, so when it is like that, then you know what is happening. So those are some of the things you need to remember. Okay. Then we go and see how best we can look at few examples. There is an exam question that we need to look at. For example, this is the question. I want you to pay attention as we do it. We have about 6 minutes left, but I believe you're going to enjoy this lesson. Now look at it. Let's analyze this without doing the question first, so that when the time is up, you know what we are doing. Okay, here is the question. We know this is a tangent, okay? This is a tangent and this is a diameter. So obviously we know that the whole of this angle will be equal to 90, because when a radius or a tangent meets when a radius or a diameter meets a tangent, the angle is 90 degrees. But R1 here is given to be 50 degrees. So if we add this to this, it must give us 90. So obviously 40 degrees plus 50 degrees will give us 90 degrees. What else do we remember? There is a chord. Look at this triangle. In this triangle, there is a chord. This is a chord, but it's a special chord called diameter. This chord here, look at it. Let me put a dot on this line. This is a chord, okay, and it forms this triangle here. So if that is the case, we can have a tan chord theorem. So this angle 50 degrees is between this chord and this tangent, and this chord subtends this angle. So the whole of this angle now, this angle, the whole of it must be 50 degrees. That is one trick you need to remember. What else can we do? You see, if this is 90 and this is 50, then obviously what angle will this be? If we add this to this, this is already 100. Plus 40 is 140. So this angle will be 40 degrees. Okay, so 90 degrees plus 50 degrees plus 40 degrees will give us 180 degrees. Now, where are we? Can we look at this one? This one, the angle is, we are taking this triangle. So this angle is 40, this angle is 50. So what can we add to it? This is 90 already. This angle is 90. Why? We can use the sum of angles in a triangle, but we can also say this diameter subtends this angle. So angle in a semicircle. So we can say this is 90 degrees. We got that one out. But what again? You see, we are not doing the question, so you can do your question later. The whole of this will also be what? 90 degrees, because this is a straight line. On this straight line, if this angle is 90 degrees, then this is 90, because the angle on a straight line is 180 degrees. Okay, but it is the whole of this angle, not only this small one. All right, let's see what else we can have. There is something interesting here, but I will see if you guys can view this properly. If you look at this diagram here, this one, if you look at this diagram, it has 4 corners. It has 4 corners. It has 4 corners, but what happens is that these 4 corners are not lying on the circle. They are not lying on the circle. So you may not know that it is a cyclic quad. Okay? What is going to happen is that we will be able to make it happen. We will be able to make sure that you know that it is a cyclic quad. All right, so what do we do? This is the first thing we need to consider. The most important thing to do is to ensure that the sum of interior opposite angles is 180 degrees. So if, for example, we add this angle to this angle and it gives us 180 degrees, then it is a cyclic quadrilateral. That is number one. Okay? And then if we add V1 to T3, it must also give us 180. Then it means that it is a cyclic quad. So, for example, if we want to prove that this is a cyclic quad, all we have to do is to find this angle here. If we find this angle here, angle P2, then obviously we know where we're going. But look at the bow tie here. Guys, look at the bow tie. Though time is running out, but wait, I'll send you another link to join the class. Okay, so don't go. You check your chat, your WhatsApp group. This 40 degrees is equal to this other 40 degrees. Can you see that? This is also 40 degrees because it is an angle in the same segment. So if this is a straight line, this 40 plus 140 will give us what? 180 degrees. So can you see that, learners? So 140 plus 40 will give us 180 degrees. So therefore, this diagram, though the four corners are not lying on the circle, it is also called a cyclic quad. Now look at this. You are to find angle WRS. WRS. Oh, wow. That is the first thing we found. This is what? 90 degrees. So WRS is equal to 90 degrees. And the reason is what? Tangent and what? Radius theorem. So you say tan dot radii or radii theorem. Okay? That is the first thing you need to remember. Okay, tan radial theorem. Then it says we should find what? Angle W. Can you imagine that? We've done that also. You see, guys, this is a very important season that we need to understand how to do this. So that one is also 40 degrees. Okay, what was the reason associated to that? That is what you need to remember. Now, if we have this, okay, so this plus this, we already have this angle, okay, angle 1, this angle is angle P2, 140 degrees, and we added this one to 180 to get what? This value. Another thing is that this angle here, because 40 is equal to 40, you are going to say this is a four-sided figure, and P1. Then if we add 50 to 90 and subtract it from 180, as you all know, this angle here will be 40 degrees. So we are using the sum of angles in a triangle to determine this angle W. Guys, are you following? That is another thing. Then I say, okay, I can still do more by looking at various angles and see what to do. And then I say, okay, what else can we see? Look at this bow tie. If you can see this bow tie, good. Yeah, I like this color. So if you look at this bow tie, the top here, P1 is equal to R2. And then T2 here must also be equal to S1. That is what we need to remember. Okay, guys. All right. That is one thing you need to remember. Now, let's go. So this angle here, P1, is equal to 40 degrees. And we know it is angles in the same segment because we can see the bow tie or we can see the butterfly. Then we have something fantastic here. We say that this line here, the whole of this line, the sum of angles on this line is giving us 180 degrees. Okay, so 40 plus 140 will give us 180 degrees. So this angle P2 will give us 140 degrees. Excellent. Wow, we're finding a lot of stuff now. Now, guys, look at what is going to happen. All right. Are you ready, guys? Let me make another fan of this diagram so that it looks beautiful. Look at this one. The whole of this angle. You see, you can see that that one is S2 plus S1. Okay, there are more learners joining. Thank you. So now this angle S2 plus angle S1 will also fall in another type of triangle. Can you see that? So if this angle is 40, okay, and this angle is 90, then the whole of S1 plus S2 will give us 50 degrees. Now we are finding more than we can be asked. So let's go to the question now. Let's go to the question now and see what to do. All right. So let me start my solution here. I'm glad you guys are with me here. This is my solution box. Okay, let's start with this question. This question says find angle SRW. Okay, find angle SRW. So, or WRS, sorry. So, WRS, where is WRS? This is W. This is R. This is S. Okay? So, I would like somebody to, now everyone you can turn your mics on and you can interact with me with this question. Okay, everyone, you can turn your mics on. I want us to talk about this. Okay, are you ready? So, now, angle WRS, what should it be equal to? Guys, turn your mics on and you can talk to me. What value is angle WRS?
90.
90. What is the reason?
Tan radius.
Thank you. This is tan radius, but the plural form of radius is radii, double I, or radii. Some people call it radii. And who said 90 degrees? Can I know your name?
Sanjana.
Thank you very much. Now, let's go to the next one now. Let's go to question 8.22. We are to find angle W. Now, we've done all the work already. It is 40 degrees. But now, what is the reason we can associate to this one?
Sum of angles in a triangle.
Okay. First of all, we can find angle 40 by saying sum of angles in what? A triangle. Because we are looking at triangle WRT. Is that correct?
Yes.
Triangle WRT. We already know angle angle R1 to be 50 degrees, and we know angle T2 plus T3 to be 90 degrees, which we did here earlier. So if this is 90, this is 50, then this is 40. So what should be the reason again?
Sum of angles in a triangle.
Excellent. What's your name?
Rayhan.
Again?
Rayhan.
Okay. Sum of angles in a triangle. All right. Let's go ahead to P1. How do we find P1?
Angles in the same segment.
Okay. So what is the value of P1?
40 degrees.
Who is this I'm talking to?
It's Sanjana.
Okay. Again, you. Okay, that's good. So this is what? Angles in the same segment. Okay? In the same segment. And learners, remember what's going to happen is that we're going to be doing level 4 questions later. So prepare. We just want to have introduction to see how best you guys can cope with this. Now, there is a question. We have to prove, okay? We have to prove. Darishan, you can turn your mic on because I want us to interact. Fatima, you can turn your mic on. Feel free, let us talk about maths now. So how do we prove that angle V1 is equal to PTS? How do we prove that angle V1 is equal to PTS? So this is angle V1. Look at angle V1, okay? And this is angle, we have angle V1, then we have angle PTS, where this is P, T, this is P, then this is T, this is S. So the whole of, let me just try to put something there. PTS, right? PTS. Is that the angle, Lennis?
Yes.
Yes.
Okay.
Yes.
Let me just put some more ink there so that it doesn't confuse all of us. Good. Okay. So now we are to prove that angle PTS is equal to angle V1. Now we've got all our values, but we have to show it now. It's 4 marks. Now, all the processes that you used in getting the answer previously, you just have to outline them down. Remember, one statement is 1 mark, one reason is 1 mark. Another statement is 1 mark, another reason is 1 mark. So you will see that 4 marks is huge, but before you realize, once you have 2 lines of solution, you are done. Okay, so let us go. Who is going to tell us how to prove that V1 is equal to PTS? Mention your name and then you tell us what to do. Okay, so who is going to lead? Who is going to tell us? We've already got the values, we've already proved it earlier in an informal way. But now we want one of you or any of you to get up and say, yes, this is how we can do it. Yes, the values are there, put them together. You write the statement like angle this is equal to that, and the reason is this, and you do the next one and that one, and then you are done. Yes, I'm ready, I'm waiting. Who is on the line? Any volunteer? Okay, do I call a name?
Angle S2 is equal to
Okay,
R1.
I want your name first.
It's Sanjana.
Okay, yes.
R1 is equal to S2 because angles in the same segment.
R1 is equal to
S2. Angles in the same segment.
again, you say R1. This is R1, right?
Yeah.
R1 is equal to what?
S2.
S2. How do you know that it is angle in the same segment? Yeah, because now let me show you something here. If you want angles to be in the same segment, then the bow tie should be able, all the 4 corners of the bow tie must touch the circumference of the circle. Are you getting it? Are you following? If you have a bow tie, make sure that the 4 corners of the bow tie are touching the circumference of the circle before you can call it a bow tie. Now, if they are not touching the circumference of the circle, then you have to prove that it is a bow tie. But now, if you say R1 is equal to S2 and angle in the same segment, then there must be a circle that is touching V1 and T3 so that to S and R before it can be angle in the same segment, unless, of course, you prove it. So let's look at other options.
Can I try?
Yeah, and remember we have what? V1 is equal to PTS. V1 PTS. Okay?
Since we got P1 as 40, we can use R2 since we got it as 40. We can use TS, and then angle at center is 2 times angle at circumference, so then it'll be 80, and then we look at the small
angle
triangle.
at center, which is O, right?
Yes.
It's twice the angle at circumference. So which angle are you referring to?
Okay. First,
I like the communication. Guys, come on, everyone should talk.
firstly, I wasn't looking at angle O. I was looking at RT, the line that bisects VS.
Okay, but before then, I want to tell you something. You see this angle O. You know that this angle is 180 degrees. Are you getting it? So angle at center, if we have 180 degrees, it gives us this angle 90, which is the same as angle subtended by diameter or angle in a semicircle. Now, what you need to do, guys, this is the trick. If you are to prove certain things, you need to look at it carefully. Where is V1? V1 is inside the cyclic quadrilateral W, V, P, T. Are you following? Look at it. W, V, P, T. It's a cyclic quad because we already proved that this exterior angle P1 is equal to W, 40. Or another rule of a cyclic quadrilateral says that if you take the opposite interior angles, you add them up, it will give you 180. So P2 plus W also gives us 180. So though the four corners of this diagram are not lying on a circle, we have already proved that it is a cyclic quadrilateral. So if you want to prove that V1 is equal to PTS, take note that you must just look for an angle that is exterior to V1. Which angle is exterior to V1?
T2 plus T1.
Watch out again. Look at this four-sided figure. Which angle is an exterior angle? Now, an exterior angle must be like this. If you have four-sided figure, okay, it must be a straight line that comes out of the diagram, okay? So this angle is an exterior angle here. Where is your exterior angle?
She was right. It's T1.
Yes, can I hear you again?
She said it's
Yes.
T1 and T2.
Okay, T1, T2. Can you see where they are?
Yes.
Look at this diagram. We have T1 here. Is that correct? And T2. Yes, correct. T1, T2. Correct. Are you getting it? T1, T2. Now, if T1 plus T2 is an exterior angle to V1, do we know the value of T1 plus T2?
No.
Good. So now I like the answer. So if, for example, we know the value of T2, we can add it to T1 and say if it is equal to 140 degrees, then that is it. But there is something, there is a nice trick here. Let me tell you this. Now that she said, are you getting it? T1 plus T2, are you following? Now that she said T1 plus T2 is an exterior angle of V1, then what does it mean? And we know already that WVP is a cyclic quad. So this is how you are going to start. You say W, okay, V, P, T is cyclic. That's the first thing. Are you getting it? W, V, P, T is what? Cyclic. Okay, because you already proved it. Where you say P1, okay, P1 is equal to what? W, which is equal to 40 degrees. Okay. Now, so what is going to happen is that, well, we can say if WVPT is a cyclic quad, then obviously once we know that it is a cyclic quad, then the interior angle, which is V1, must be equal to what? The exterior angle. That is one theorem. That is one of the examples, but there are many ways of doing it. So you can say now angle angle T1 plus angle T2, okay, is equal to angle what? V1, okay, which is equal to 140 degrees, which is exterior angle. Is that 140 degrees?
Yes.
Yes.
No. This angle P2 is 140. Sorry. This angle P2 is 140 because 140 plus 140 is what? 180. Guys, are you following?
Yeah. Yes.
Yes.
Guys, are you following?
Yes.
So you cannot use this angle. Are you following?
Yes.
That was why I was saying that there is a catch about her problem, because if you use that, we already know that this angle T1 plus T2 is an angle that should be equal to V1, but we also don't know the value of what? V1. So you don't go that way. Now you can see that there is a catch. You can't use this one now. So now you must make sure that your V, you see, this angle V1 must be equal to this. You need to look at certain things that you can do to make sure that those two angles are equal. If they are equal, then you are done. Who else is on the line? Can I clear everything on the page? Or you are still writing something? Dennis, can I remove the writing because the writings are too many on the screen?
Yes.
Yes.
Okay, good. Now, good. So we are saying this angle V1, the examiner says it is equal to angle PTS. PTS. So if we are able to know, because we already know this angle, we already know this one to be 90 degrees, right? Okay. So, and you already know this angle to be what? 40 degrees. And you know this this angle to be 140. And you know this one to be 40. This one to be 50. Then this one to be 40. And then this one, the whole of this, but we should have another way of finding any of them. 50. Okay. What else have we found? Okay. So now let us take time, be patient. We know that angle T2 plus angle T3 give us 90 also. Okay, let me just write it down so that we don't forget. Okay. So now, if we want to prove that V1 is equal to PTS, what do we do? Because that is the only thing we are looking for. Which idea do you have there?
Sir?
Yes, I'm here.
So, okay, since we know that T1 is 90 degrees, right?
Yes.
We can say that PTS is equal to 90 plus T2.
Okay, let me write your information. PTS
is equal to 90 plus angle T2.
Okay. As was already said, right?
Yes, sir.
Okay, good.
Then, sir, we can say that T2, sir, is equal to S1, sir, because of angles in the same segment.
You are now talking. So T2, okay, is equal to S1. Now, let's look at that. Let me take another color so that I trace that thing properly. So we have this bow tie. Yes, good. Okay, my drawing is not perfect, but you can see that if the top ones are equal, then the bottom ones are also what? Equal. That is the angles in the same segment story. So, yes, I agree with you.
Then, so we can make the assumption that PTS is also equal to 90 plus S1.
So we can also make assumption that
PTS is equal to 90 plus S1.
90 degrees plus S1. This is an excellent observation. Excellent observation. Yes.
Because actually it's not the assumption, it's because of T2 being equal to
Yeah,
S1.
that is why it's an excellent observation, because you call it an assumption, because in maths there is no assumption. So all you need to know, what I like about the way you guys are responding is that the diagrams I showed you earlier, if you just remember them, you are done. Because for both tire, if the top two are equal, then the bottom two are also equal. That is the aspect of the whole problem solving. Okay, now, so you see what we've done now. So where shall we go now?
Okay, so then from here we can go and we can say that V1, sir,
Okay, our V1
is equal to 90 plus S1.
Our V1 is equal to 90 degrees plus S1.
The reason for that would be it's an exterior angle of a triangle.
Okay, let's see. Which triangle are we talking about?
It's triangle
VRS.
VRS. Yeah.
Yeah, I can hear somebody's voice now. Whose voice is that? Whose voice is that? Why are you hiding behind the microphone? Okay. So this V, you said V1, right? It's an exterior angle of this triangle. And the rule says the exterior angle of a triangle is equal to the sum of the opposite interior angle. So let's say the whole of this angle and the whole of this angle. Is that what you're saying?
Yes, sir.
Okay. This is 90, this is what? 50. So that's obviously what? 140.
140.
Yeah. Okay, so now let's go to the main point. What are we going to do now?
We can equate PTS sir, to V1, sir, because both of them are equal to 90 plus S1.
Okay, so we can now equate what?
PTS to V1 because both of them equal to 90 plus S1.
PTS, right? Let me put my T properly. It's equal to?
V1 because both of them are equal to the same things.
Because now it's reversible. You can say V1 is equal to PTS or PTS is equal to V1. Now, what I want to say is, learners, everyone who is on the page with me, I must say that I am impressed about your time consciousness, and two, that you are eager to learn and then pass your metric, not only with a pass, but with distinction. What is going to happen is that if you look at how we analyze this question, this is exactly how you have to do it in exam. Take note. So when you take a question paper, do not jump and start answering the question or reading the question. Make sure that you first analyze the diagram, write all your values down. So after writing your values down, your solutions are just going to come from all that you have written down. Are you following? And that is what I want to say to you. We wouldn't have enough time to do more, but like I'm saying, I just want to encourage all of you. We're going to continue this. I want to make sure that every Monday around this time, we have a lesson. I will try to do that. Then I am also going to send you a survey. So those who are not in the WhatsApp chat group, please join the group. Or otherwise, I can write the WhatsApp number here on the screen for you. The WhatsApp number is 031. Okay, 031. I'll write it somewhere. Yeah, it's 0.
So you can post it on the group, sir.
It's okay. I'm just writing the number here for now because I don't know if some of you are on the chat group. 714 91
But sir, it's written there.
46. Okay. So yes, it is also written down here. Now, what is going to happen is that we will do this every Monday. I am also going to send you a link, which we call a survey. And I encourage everyone, the moment I put it in the chat group, please try as much as you can to reply to the survey. Okay? So that we know, because I want to know what plans we have for the next lesson that we're going to have. Please post all the topics you want us to do so that we can just put them together and help you with it. Thank you very much, and God bless you. See you next time. Bye-bye. Bye.
Bye. Thank you.
Bye.
But how was the
Hi.
lesson? I didn't even ask you how you felt. How was the lesson? I didn't even ask you.
It was very useful.
Was mwah.
What do you expect? What do you expect in future?
It was very enlightening.
Again?
It was very enlightening.
Okay. So what do you expect next time? That's what I want to know.
The same thing as today.
Well, might do examples.
Okay, more examples,
Okay,
right?
I will see you soon. Bye-bye.
Yes.
Okay, and we will just pick the questions from the past exam papers, so no problem, so that you can prepare well. Thank you very much.